Good day, ladies and gentlemen. Our team will be presenting the sustainability of ASTI-developed technologies and meteorological data acquisition stations for information dissemination, or MASID. MASID focuses on maintaining government efforts in strengthening the country's disaster preparedness and mitigation plan. From the project's name, sustainability, it will ensure the continuous operations of the deployed field sensors and the field sensors portal, which was funded under other 6 different disaster mitigation projects. The first of which is the hybrid AWS project that ran from 2010 to 2012. Next is the deployment of hydromet stations under the hydromet project from 2011 to 2014. Third would be the Met Buoy project from 2012 to 2015. Then comes the Agham climate change project, which was implemented from 2012 to 2019. Followed by the urban flood project from 2013 to 2015. And last but not the least is the DOST project from 2014 to 2017. MASID project is in line with 2 harmonized national and research and development agenda of the DOST, which are agriculture, aquatic, and natural resources. The agromet data gathered are used for informed decision-making on what crop to plant and on what location, and disaster risk reduction and climate change adaptation. The ARQ and field sensors are innovations used to remotely collect near-to-real-time weather data and alert communities of impending disasters. MASID aims to ensure the continuous functionality of the technologies, which are crucial in forecasting and in minimizing natural or man-made catastrophe. Specifically, MASID shall maximize the purpose of the field sensors to ensure the sustainability of its operations, transfer the ownership of the field sensors to agencies that greatly benefit from the data that the stations collect, maintain the operations of the receiving, storage, and visualization of data collected, and continuously provide raw weather data to stakeholders for research and policy making. This project is about the ASTI-developed products and systems for environmental sensing and early warning. In the slides that follows, we will show you our locally developed ARQ, locally engineered field sensors, and in-house created field sensors website. Here you can see the timeline to when the technologies have been developed and improved over time. So in 2010, we have developed the AWS, WLMS, and box-type early warning system. For 2011, we have completed the design of the ARQ. Then in 2012 is ARG, updated WLMS, and tandem station. This is followed by urban flood, Met Buoy, and agromet station in 2013, and finally, in 2014 is the current design of our early warning system. Our locally designed and developed Advanced Remote Data Acquisition Unit, or ARQ, is the brain of the stations. It collects data from different environmental sensors and sends it wirelessly at a specified time interval. The Institute has also registered the ARQ for intellectual property under utility model and is now currently being mass-produced. Our field sensors are categorized into 5 types: the hydrometeorological stations, agrometeorological stations, urban flood monitoring stations, meteorological buoy, and early warning stations. These technologies were deployed and designed to automatically gather on-site weather data. Here you can see the designs of each of our stations. In the next 2 slides, we will show you the field sensors on the ground. First is the hydromet devices, or stations. which are the tandem station, a combination of WLMS and ARG, WLMS, AWS, and ARG. Next are the Agham station, Met Buoy, Urban Flood Station, and our Early Warning Station, or EWS. The EWS has 3 sirens for omnidirectional sound reaching up to 300 meters. It also has 4 warning levels: the alert, alarm, critical, and recession, and it can be triggered either manually or remotely. So here is how our system works. The field sensors gather data and send it through SMS or satellite. The GSM gateway server receives this data, and then a script processes it before storing it in the database. All the data are shown near real time on the field sensors website and shared with end users via API. This is the summary of installed field sensors per region. Overall, under the 6 previous projects, our agency is currently maintaining the functionality of 2,292 field sensors. Kindly note that some of our hydromet and early warning stations are being transferred to DOST Pag-asa under the optimization project. Now, this is the field sensors website developed to provide the public access to both historical and near real-time weather data. In this site, you will see the data gathered by our AWS, ARG, WLMS, Tandem Station, and the Pipoteka and Vipoteka for the ULAT project. On the right side, you can filter out the type of stations you want to see on the map. On the upper left corner is the search box to see the data of an installed station. You will see the status, and you can download the data as image or document. Clicking the Data Visualization tab, you will be directed to the next page of the site. You can type in the field sensors you want to see in the search bar, and you will see the graphical and tabular data of the field sensor. In 2017, we were able to publish and present the research paper entitled Hydromet: Deployment of Large-Scale Nationwide Hydrometeorological Sensor Network for Flood Warning and Monitoring at the EEGHTC 2017 conference in San Jose, California, USA. In the implementation of the 6 projects before MASID, we have conducted a series of IECs and flood drills, training for staff in maintaining and troubleshooting our products, and sharing our historical and raw data. We also give API accounts to individuals and concerned agencies after the accomplished and signed End User Licensing Agreement, or EULA. So far, the active API we have authorized are distributed to 26 government agencies, 22 state colleges and universities, and 6 non-government and private agencies. As proof of our field sensors' reliability during disaster, this is the EWS in Minangasur, Cagayan during the onslaught of Typhoon Tisoy in December 2019. Our data were also used by Project eSmart in the hydrologic models of May Kawayan River and Bulacan River Basin. Field sensors data are also used by other services of ASTI, such as DATOS and PEDRO, to complement the satellite images. Another milestones would be the patents and IP registration on all of our field sensors projects. Beginning 2012, we were able to register 4 of our products, and then 15 in 2013, 1 in 2016, 9 in 2018, and 3 in 2019. For our partnership, we have installed our field sensors in 86 cities and provinces. These cities and provinces can use the field sensors in relation to their disaster risk reduction activities. Likewise, data gathered from the field sensors are given to the end users after an accomplished and signed EULA. Our future plan involves enhancing the current ARQ to address some of its issues under the project called ARQ version 2.0. Also, as part of ASTI's Technology Licensing Office responsibility, the unit is assessing companies that may handle the production, distribution, and installation of the ASTI-developed technologies. That's all for MASID project. Thank you very much.